Hello, Internet. Time for some SolidWorks modeling. Welcome to Fully Defined. My name's Chris. I'm a certified SolidWorks expert, and I am in the process of modeling this Lego motorcycle. In the description, you might find some links to previous streamed or previous parts that we've done. Throughout the stream, I will show
and being able to build an app with you.
I will show some locations you can find more information on the project and join in. There's also links to the Discord, link to the school community as well. And there is a link in the description of the video to sign up to my email list, which will give you access to Google Drive, which includes all the SolidWorks files, 2023 version, and some step files. I don't have steps for the motorcycle parts yet. They will come at the completion of the project. Right, now, there's no one in the chat yet. Tell me what to do. So I'm going to get started and choose the parts that I want to do first. Here is our list. Here is our list of parts. Through many of those already. The ones with the green dots. I'll see those in my assembly in a second when I flip over. The one yellow, we have done very similar parts before, and so we only need some with modification. And then the orange parts are completely new. The ones we're going to model from scratch. Hello, Kev. Thanks for mate. How are you? Going well. I'm continuing on with the model. Might not be a long stream tonight. Through a couple of parts, I hope. Let's get started. I'm going to start with these two red ones over on the left. I do have this zoom cam here, which lets me show the detail and explain up close, how we reverse engineer what we can see in the part. And if you have any requests or questions throughout the stream, feel free to type a message in the chat or jump on Discord and let me know. If there's anything you'd like to see workflow-wise, or you had specific questions about how to do anything in SolidWorks, modeling or design-wise, happy to help. Okay, so we're going to jump on to this one first. And I will just zoom in the camera to get that a little bit bigger. Don't want it too tiny. There we go. All right, so if we have a look at this part, just before that, I'll show you the other parts that we've got here that we have already done. So in the last week, I updated the detail on a lot of these small connector pins. I haven't recorded that detail. I don't think it's too interesting, but they were ones that we had to get done for this model. So let's have a look at this one in detail. So this part is called let me find it. Now I'm referring to the website Rebrickable. And if I look for this part here, is this one a Technic axle and pin connector that is perpendicular. So this gives us good reference material to build from. Toby, good morning. Thanks for stopping by. Big day for you, mate. I'm very excited to watch the replay when I wake up. Hope it goes well, mate. Really excited to see how Ace Artsay goes with all the training material we've been doing on the side. I saw him mention that in the interviews last week. But in our Tuesday night streams, we've been doing quite a bit of spelling practice. We did a lot of tier 5 models this week. So Artsay should be all ready to take it right up to recovery. You're welcome, buddy. Best of 5 too. I'm really excited to see that. All right, so here's our first part and how we're going to approach this. We could do it one of two ways. It is symmetrical. So we see the symmetry that goes up the middle here. Both sides of that axle connector are the same, and the slot goes all the way through the middle too. So we only have to model half, which will speed things up. You can start with either the top or the bottom. I'm going to start with the bottom. I'm going to start with the top component and put that on the origin right in the middle, and then build out from there. Let's get into it. We'll start this with a new part. And pretty easy one to start off the day. Caliper's ready to go. Now, if we wanted to cheat, one thing that we could do or save time is grab this Technic bush, which we have done, because this has actually a lot of the detail in it already that we need. We could create a new version of this and build this file, and I actually think that's quite a smart move. So what we're going to do is grab the file name here. I'm going to save this as a copy. Just go to the right file. I'm in the motorcycle folder. I'm going to save as a copy and open. So I'm not overwriting the original file. That still stays there in the assembly. But this gives me a fresh version. I'm going to close the original. And now that file name has changed. I'm ready to edit this part. Now, there are some differences, and I will just check some dimensions, but it will save me some time. First difference is on this version, it's around the outside. Whereas on this original one here, it had these little cuts on one end. So we can remove detail and remove this detail here at this end. It might take a little bit more playing around to get that right. We'll do that now. Right, so this extrude thin, what I'm going to do is change. Just going to look at how I modeled the first half on this side. All right, so at this point it's symmetrical. If I roll down that rail, I'll mirror to the other end. So let's have a look at how I modeled it, where my planes are. My front plane, unfortunately not in the middle. That's okay, but we will modify that. So I'm going to update this extrude here, and I'm going to change this one to mid plane. And then my cut extrude still goes end to end. My thin extrude, all I have to do is change the starting point for the extrude. So instead of starting from the sketch plane, I'm going to change it to this surface face here. All right, and now it's going to start from that end. Now I mirror that detail, because if I try and mirror the feature, it's looking for the same surface, different position. There are ways to get around that, but just to show you how I can repeat the step using that same sketch. The thickness of that is 0.85 and it is 1.6 deep. So I can grab that sketch, do a thin feature, 0.85, and this, take it from this face and then put in a new dimension. Hey Will, thanks for the question. Is there a good way to locate the holes on the bottom with just the physical model? Yes, there is, and I will show you that in the next step. Hello, Jen. How's it going? Thanks for jumping on. All right, so let's just quickly roll down. Okay, we'll just get through these other features. So I no longer need this extrude thin. Cut extrude here is the slot. I'm going to have to just update that sketch. All right, now that slot's going to, in its same detail, I just have to move this back to the origin. Okay, that's looking pretty good. Yeah, fillets on the outside, but I'm actually going to roll that back or suppress that and keep that for later. And this other cut, that no longer exists. So if I'm looking at this here, it's a bit hard to see. I'll zoom in a bit more. You can see that those sections there, they're up at this, they're up on this face. They're not offset down. So I'm going to keep them with that. I can delete this cut extrude feature. And now I can continue on to the next part. So I'm going to roll above that fillet. I'll use it again later. But this is to wheels quick. Is a good way to locate those holes on the bottom. So the way to do that wheel is we can measure the outer diameter of the holes. So with the calipers, and go from one side to the other. See they're about 7 point. Here I round up. So we can go on to what will be our right plane now. So each hole is 7.4 on the outside. The inside of the holes, we can also measure. You can see that 4.9. And we have 2 of these circles. So I will mirror them, but I'm actually going to mirror later the features. So I don't want to double up and do the features twice. I don't want to do the sketches twice. I'm going to model one side, including this little down. In fact, I could just do a quarter of it. So I don't even have to do the full width depth. I can just do from the middle out. All right. And then I can do a double mirror, and that's going to join them all together. Get the right position. Because we're able to measure here the inside and outside of that hole, and we know that there's another one on the other side, if I can measure the outside of both holes, and I can see that 4, I can do a sketch. Actually, I don't even need to do a sketch. I can use the construction line here. I can hold Shift on my keyboard, click on the outside of the circle, and then as I move my cursor across that construction line, I'm going to get basically like a dimension across all the way. So it's here, I can put in that 15.4 mil dimension. And even now mirroring that, I know that I've got the right width. And the next job is to do the height. And for the height, I can kind of do the opposite, just rotate it around 90 degrees. I can see that actually the same dimension, 15.4. And so from here, I can do the top edge. Now, it can be difficult to select sometimes, just got to get really close. Shift on the bottom, 15.4. And now that circular component, that's fully defined. The width of this is going to match the top part, which is 7.8. Now, dimensions. When we extrude it, I'm going to divide that by 2 and just go one direction. So what dimension do we have here? Just double check, 7.4. So this one's a little bit undersized. Let me just check the width part. 5.4. Yeah, so it's this element here that needs to go up. Okay. So that should be now 7.8. All right, so that is looking much better. Now the step down on the inside, it's too small to measure the depth of that step, but we can measure how wide it is. We can see it's 5.5. I think we can assume that it is about 1 millimeter deep. So I can convert this edge. I can do an offset. Or I can sketch that circle with the dimension, because I said 5.5. Let me just measure that again. That looks a bit small. It's 6.2. I must have had the wrong spot earlier. So 6.2. And now extrude down, and we'll just go 1 millimeter. Okay. Pretty neat. Now, before we do our double mirror, there's a few other features that we can put in. First one, just going to check this width here. It is 9.5. We have here quite a bit bigger. So I'm going to scale this one down. That should actually be, let's take it back to 1 on both sides. So on this face, I'm going to see how it's closed in section. I'm going to fill in that area. I'm going to grab all of this. And I'm actually going to go down a bit lower by just changing my view to through all. I can see. And I'm going to use that as a guide there. I'm going to come across to the middle, up, and I'm going to invert that edge. Okay, so that gives me an area that I'm joining onto. I'm going to extrude up to surface to close in that part of the shape. And all we've got left to do is this section here. Okay, so where we've got material. Now, I can't measure how thick that is, but I'm going to assume it's about 1 mil, same as everything else. So if I do half of that, we're going to do 0.5 meters. We can also see there's going to be a little gap between those two cylinders. That's filled in with another thick part there, which is comes up to that top face. 1.3 mils. So we'll join that into as well. So on the right plane, do a sketch. I'm going to use inside face here, come down. This last middle, I'm going to go down to around here. I'm going to convert that edge, and then I'm going to sketch in on this side. And then all that's left to do is dimension how deep that comes. Now, I don't think I'm going to be able to get the calipers in to measure that. I can see it's just past the center line. So I think we'll be safe if we put it in a little bit over. And extrude it this way, 0.5. Right. Now I'm going to see if we can do a double mirror for all of this detail, which includes this boss, this cut. Now I'm holding control on the keyboard, this boss, and this boss here. I press mirror. My face plane is this face here in the middle, and then this face here on this side. Press OK. Now I'm getting some errors. Merging features may be patterned if appropriate. Make a pattern of bodies instead. We could do it with bodies. We just see if geometry pattern solves this for us. No. Right. Instead, because everything's symmetrical, even though I don't need to mirror all the bodies, I'm going to do so here because it's going to save me time. All right, so there's quite a bit that's going to, but the end result is going to be, I believe, those two outs different. We'll fix those up. Be the part that we need. Now, what's happened here? This one's 7.4. This one's 3.9 at 7.8. So this one was a little bit off. So we didn't update this detail. But you know what? Now that I've got it here, it shows me there's a few things that I could have done more efficiently in this model, which would include doing not doing this thing extrude twice, knowing now that I'm going to mirror it. All I'm going to do here is actually just delete this one and update this sketch. That tangent. Okay. Let's get even more efficient. And instead of going mid-plane, we'll just go blind 4. Okay. Looking pretty much more efficient now. Delete that midpoint. All right, now when we roll down and do the mirror, it's a much better result this time. All right, is it? Just probably a couple of small. That's where I kept this original fillet that I had. It was a 0.2 radius that we put on a few edges. You can see kind of in the highlights that they're not sharp. The camera can't quite focus in that small, but they're not sharp edges. You know, they've taken a bit off. And when you get a joint here, it's not a sharp edge, there's a very small fillet. So we'll put in those by selecting a couple of those faces, select a couple of the internal faces. No, I don't want to select this. I could do this one here. Okay, there we have it. Right, neat part done. Let's drop that into the assembly with everything else. And that's another one we've ticked off the list. So one thing that I am building, which will be, let's say, available at the end of the project when I line up everything, put all the files in the right place, is this Lego library of SolidWorks parts. So a bit of a parts library that I'm generating. At the moment, just the motorcycle parts here, but I am filling this out. You'll be able to see if you're doing some, let's say, which parts are available, what kind of difficulty they have, as well as what kind of features they use. Now, some parts might have very small configurations or symmetry, and some might have more advanced features. So eventually this will be available, it'll be something that people can check out. You can open up the file, you can recreate it yourself, or you can use it as reference to go alongside the recorded lesson, which you can see all of them shortcutted here. Just thought I'd show you guys that. Links to all this will be available in the fully defined school community, which I'm building. In the classroom at the moment, I've got a couple of classes for the Lego series I've done previously. And the CAD library is work in progress. So coming soon. I reckon, Kev, if you had a look at the way you modelled and the way I model here, there'll probably be a lot of similarities, and then every now and then there'll be some like key differences. Depends you know, whether you're just trying to get through it or try and be like super efficient with what you're doing. And in some of the parts that I do as well, I am leaning towards using certain tools because I'm trying to teach that as part of, that series of parts. So it can be a bit different. Hello to anyone out there that's just joined. I'm modeling a couple of parts for this Lego set, the motorcycle. And I'm about to move on to my next part, is a much more complicated one than what we started. Or should I go for one? Don't know, what would you guys rather see? Another easy one? I'll give you the options actually like that. So I've got this part here. We have this one we can do. Pretty simple, just like what we've created. I've got this one I've done before, but we need to convert it into this so I can show you how we can modify parts in a very similar style. I've got these two. So I've done the black one. I need to do this grey one so I can show you how I can modify that part. Or the other one I want to do today is this wheel hub, which has a lot of patterns, revolve, some thin features, maybe some ribs. Yeah. Anyone in the chat want to pick which one I'm going to do next? So we've got the red one. We got up with the angled arms or the hub. Let me know. Everyone's busy. Waiting for the stream to catch up. While you guys decide, I'm just going to grab a print off the 3D printer and back. Okay. Anyone pick? No? All right. I'm just going to go for it then. I'm going to do the... I want to do the wheel. I want to see how that fits with my other parts. So let's jump into that one. Excuse me. That print fell away. By the way, on the print thin. Need to try that again later. Okay, hub part. We'll just look it up here. It is a wheel 30.4 by 20 without pinholes. And we have a look at the detail. So it's going to fit into this tire. Jen, you want to see the black angle? Let's do it. All good, guys. And no stress. All right, we'll do the hub next, but we'll do the modification. So what we're going to do is convert this one to this one. Okay. So we'll try and do this as efficiently as possible. Obviously, there's a lot of similarities between these two. The angle's actually the same. It's a 45-degree angle or 135. It's really a number of patterns. If I've set this up in the right way, I don't need the zoom. Yeah, this one should be very quick. Let's have a look at how I've built the original. And let's save our duplicate version. So we're going to be creating this longer version. This is our part name. All right, we're going to save as. We're saving as a copy. Close the original, okay. I think I cheated. Right, I had half a section, and then I had to combine a pattern. I patterned it and the combine. So a little bit funky how we did it there. Also, I had the measurements wrong. But it's not 100. The angle I had in that was quite weird. So yeah, but I'm pretty sure I measured it. No. Anyway, yeah, we will move on from this one. So we're going to convert it to this. Good example here. We'll show you how to hack a part. I mean, it's not best, but sometimes you just want to do something quick. In this example, I've already got this. I've already got the features I need. I've just got a different number. So I'm going to use some split and move tools and pattern tools to just add in the bits that I'm missing. Okay. So I'm just going to roll back before the combine, and even to this point, and just see what I've got here. Now that length needs to change. All right, so I'm going to edit this feature and bring this all back a step. So the extrude length, because I'm only going to 3. So I'm going to reduce that by 8, minus 8. But I'm going to change the whole number. Whole number is going to change to 3. And I need to update then this last hole to be on this point here. All right, that's the first step. Very, very quick hack. We haven't hacked anything so far. We've done that properly. Second step, we've got those 2 circles. Those are good, and those be mirrored. All right. So we've got that little step down on the second 2 holes. I'm just going to remove the color so it's a bit lighter. Okay, so that's looking okay. Got the cut through. Now this one I need to tweak. But all I need to tweak is delete that sketch, edit the feature, and change the selected contours. I can clear them and select these contours here, and that's going to very quickly update that element. Now that's just through one side, because then what I've done is the boss extrude here all the way through, and then I've cut that sort of shape deep on the end there. I needed that all the way through as well. Now I can mirror this cut on the other side, and then fillet all of them. Now the fillet's going to have some dangling edges. Why it goes to the error or the warning. But all those missing edges, I can just right click and go clear all missing references, and it will keep the good ones and remove the dangling ones. All right, so now we have, like, say, this first section of that part is done. So now the hacking part. So this is where the sketch was that I'd done previously. Now, that was my sketch to validate, kind of confirm the angle. This one is a little bit different. Let's first update the pattern, and it's the axis of the pattern that we need to change, which is the circular face here. Right. So we've done that angle. Now I need to adjust the scale, adjust the size. Zoom in a little bit for you guys there. Okay, so I want to move it out, and move it out another 4 places. Now, thankfully, I know how the dimensioning works, that every slot is like 8 millimeters. So what we're going to do is a move copy body feature. So that's move copy body. I select this body here. I'm going to set translate, select an edge to give it a direction, and I'm going to move it 4 times. But I'm going to press minus to flip the direction. Now, if I've done that correctly, then if I was to do, let's say, another 4 of these holes, let's say with a linear direction that were 8 meters apart. So I did 4 of them. Then when those are all lined up here, get that one lined up, get this lined up here, collinear, sorry, parallel. All right. That looks like the spacing is spot on. If I change this to 5, yeah, right in the middle. Okay, so I've got my right. 3, 4, 5, 6, 7. 4, 5, 6, 7. Okay, the spacing is good. Now I'm going to hack the rest of that. So, as of doing that, what we really need to look at is the geometry that we want to keep and how we want to replicate it. And if you're looking at it, it's this face here, this round face. I don't need that because on this end, I've already got it. So I can get rid of that. Also, I don't need this end. I want to get rid of that. So what I'm going to do here is I'm going to do a split. I'm just working out where to do the split. So the one thing I do want is this. I want that to be repeated. A few times. So yeah, the split can be a little bit complex. I'm trying to do it so I don't have to do any sort of finishing work after I've done that split, which would suggest I want this edge moving around, and when that comes to the other side, it's going to be equivalent to this edge here. We'll see if this works. This is a little bit of an experiment. So this line is going to be perpendicular. Going to have these on it. And I'm just going to put a dimension on that of 1. That looks about right. trim the middle section. And I'm going to repeat that. So I'm going to do the same thing over here. So it's going to be perpendicular. I'm going to put this one here, this one here. I'm going to trim this. And then I'm going to make these 2 lines length. That's going to fully define this second one. And then I'm going to use features split. So I'm going to split the body using cut bodies. And I'm going to select the middle body. By selecting the middle body, it's going to split the other 2 anyway because it's dividing them. Press OK. Now, this is a separate body. We no longer need it. I'm going to hide it. I'll delete it later. This one, we want to pattern it. So I could do move copy body like I did earlier. That does have the ability to do multiple copies. So I could do select this body and do multiple copies on this this direction. This is one way to do it, but this feature is not as strong as the linear feature tool. Linear feature tool is the proper one to use for the kind of thing we're doing. I'm going to select the body. I'm going to select this edge. I'm going to make the distance 8. I'm going to flip the direction. I'm going to make it 5 instances. So it includes the 1 instance we already have. And I'm going to press OK. And we can see the end result. This is pretty good. What I'm now going to do is do a combine tool. I'm going to press add. And I'm going to select all of these bodies and combine them back together, which has worked. And then all I've got left are these little sections here. There's a few ways of dealing with this. My favorite way, if it works, is delete face. And I can do that to both sides with the one feature. And then my very last step is remove the other body or keep this body. And there we have our new part. It was pretty nice. That worked pretty well. All right, I'm going to save. And what I do for my colors is I create configurations. So I'm going to create the configurations as dark gray. And I'll add a to it. Save that. Bring it into the assembly. What do you think, guys? Pick up some nice tricks from that one. I think dark grey is a little bit too dark. Monty, question: how much is recommended to get proper slide fit of plastic parts? Great question. It depends on a lot of factors. Depends on how big your job is. So are you dealing with something in millimeters or centimeters or bigger? At this scale, if they're injection molded, you probably want 0.2 of a millimeter. There are very interestingly in this series, these friction pins or these connecting pins here. You can actually see that some of them have these friction ribs on them. So that, like if you look at these two here, this one here is intended not to spin. in the part, but this one is. And I think the height of this is about 0.15 of a millimeter. For context, the diameter of this is 4.7 millimeters. Awesome, Jern. Got to get delete face in there. Very important. Hope that answers your question, Monty. Anyone else with any other questions, feel free to chuck them in the chat. Right, that was a good hacked part. Some neat tools. I'll regularly use, split features, combine, move, copy bodies as I'm building out concepts, things that I want to test quickly. Just get it done, hack it, 3D print it, test the prototype. Once it's validated, then I'll go back and update the geometry and do it properly. So it's parametric, so that other people can understand what I've done, so that it's not going to sort of break if certain geometry changes. But the process works. All right, let's do the part. Hub. Yeah, exactly. All right. This part that we see, we've done a couple of hubs before, but they're always a little bit different. It's going to be difficult to measure some of this internal detail, but most of it is patterned. So we'll be using some circular pattern features. Interestingly, you can see on these features here that they're not complete ribs, like there's a gap here where I can stick that tool. So yeah, they're kind of spokes, but not quite. Those holes go all the way through. On these faces, this element looks symmetrical. There's kind of a chamfer on these inner faces that we'll put in. There's a hole here, kind of looks like a gate area for the molding. Another one over here, which actually has, if I get the lighting right, it's got the part identification on it, Lego and the number. But a bit hard to see here, we can't quite zoom in enough. And on this side, some smaller detail as well. It's got a bit of a dome face there. That's going to be very, I probably won't be able to measure that. I'll have to guess. Cool. Kev, let's give it a go. All right. So we'll start with the easy stuff, which in this one, you're welcome, Monty. We'll start with the new part and, the overall geometry, which we can use, the outside stuff that's easy to measure. So we will do a revolve. We're on the right plane. And can't remember which way is the front. Maybe we'll think in this model. It's only one wheel, so there is really no front to back. That doesn't matter too much, actually. Stick to this side. We'll try and get as much as we can in one go, but yeah, we might leave some details to simpler features. We'll try and get this outside shape done. So these ribs here, we skip those because they'll be done with a pattern afterwards. Get some of this inside. Let's go. So I'm going to start with just a construction line in the middle. Then my first be the outside. Just going to get the diameter. Pretty sure it'll be symmetrical. 30.4. The part website on the website says 34. So it's going to be here. Just want to get the scale right with that first dimension. And we'll make this side the front. So what I can see, there is a chamfer. So it's flat and chamfer down. I'm going to roughly measure what I can see for the section. About 2 millimeters. Down 2 and then in. It looks like 45 degrees. I can measure between the faces, which is 24.7. And it's pretty straight. It's not going to be perfectly horizontal, but we're going to draw it that way here because we're not going to draw a draft that's too small for us to see. I'm going to leave it like that. So that was 24.7 in here. And a 45-degree angle, we are assuming. We can't accurately measure that, but I'm pretty sure it was. Then at the bottom, there's another angle, another 45. Can we depth? Going to be pretty difficult. If I get my calipers to slide, that would help. Just using the end of the caliper to try and get depth. Not doing too successfully. About 5 millimeters. So that's this one here. Goes about 5. Then there's another 45-degree angle. Yep, that's already parallel. Good. And then there's the domed face. So the bottom of the dome face can at least get about 10 millimeters down. So what I'm referring to here is there's another little step, and then there is a round face like this. Now the center point of that will be in line. And I could measure that this was about 10 or 11 millimeters. Let's look at 12 and see how that goes. Chamfer at the bottom is a bit bigger than the one at the top. This one we hadn't measured, but if we have a look, it's 0.85. In CAD, I'm going to say this one might be 1.5. That little step down, pretty small, might be 1. Okay, and then that gives us fully defined. We are guessing to the depth of this curve at the bottom. Now let's sketch some of the outside. So we have a flat section, which is 1.6. I'm going to put that one in, 1.6. Then there's a step down, back up, down, chamfer, which would make sense to be in line with this one. It looks like it goes pretty deep, and then step across, and that's to the middle, what looks like the middle of the wheel from the outside. So a couple of sketch features we use here. These lines will be collinear and equal. I think they're both 1.6. 1.6. And then we can measure the in between them, 27.1, 27. So that's this one here. Yep, right. The width between those two gaps to the outside of them, you get 5.3. So that means it's 5.3 there. Now let's assume that these two are parallel. And let's assume that there's a nice consistent wall thickness between them. I can't quite measure the depth of this because all the ribs are in the way. Unless I can get this dimension here. I can get it, sorry. 24 millimeters. So here, 24. Let's make the width of this 1 millimeter. That looks pretty good. Maybe a little bit less. What I'm looking at judging is like how deep that one is, how deep this one is. Okay. And this is like symmetrical on the outside, so I can grab all of this detail and let's put in a constructor goes through the middle. So I just put this on the midpoint. I'm going to go mirror entities. Now, not everything on the other side is symmetrical, or is it? Feels like it is. So everything on the curve here could be symmetrical. Sorry, this is what I have. So I'm referring to, if we have a look here, you can see there's a step, chamfer, step that goes in, another chamfer, another step down, and then the curved face, which runs around here. It's a bit harder to see on this side, but it looks like the same geometry's there. Step, chamfer, step, chamfer, step, and then the curved face. I think it's fair to say it's probably symmetrical. So what we'll do is grab mirror. I'm going to grab all of this, mirror about this one, okay? And then all we do is set the width, which is pretty easy measurement. 20. I'm going to grab all of it, put 20 in for the overall. Then I just have to adjust this element in the middle. And what I can actually do is delete that and just extend that segment all the way across. All right, so the outside looks really good. Now we can see that this inside is probably going to be too far apart, which tells me maybe this step, they're not quite symmetrical. It looks like on this side that last wall is deeper, and that would make sense looking at our sketch here. On this side, it's definitely not as deep. So that's this one right here. Now, you'll notice that it's fully defined, this line. Can't extend it. Now, that's because it's a mirror of the other side. You see this point? Mirror. There's a few ways you can go about extending it. You could draw in a second line segment. I wouldn't do that. You could also delete this relation and then move it further. Or what I normally do is just grab my trim tool, power trim, and I grab the line and extend it out a little bit. Now, once I extend, it loses that mirror relation, so it's no longer horizontal. I want to make it horizontal again, but then I can drag it in a new dimension. Now, again, this one's pretty hard accurate. I think I'm going to have to do this one by eye. that we're looking at about 4 millimeters. How does that look? It's a bit too much. 3.5. And then I'll offset this one. Just that section, 0.8, reverse direction, okay. I'm going to remove dimension. I'm just going to trim those. Now it's fully defined. And there is my complete profile for the revolve. I'm going to hit revolve, hit the construction line. It's okay. It's the outside of the wheel. You grab the name and we'll save it. At this point, we do not want to lose this one. All right, looking good. So now a bit more detail. First up, let's go to the front plane. I'm just working out which way is up. And I want to get this, see the X hole. I want to make sure that's up and down. So that's going right here, which means the holes that are going to go through, they're actually horizontal. 6 of them are aligned on the side. There's 6 of the rib pattern, so there's 2 either side, but 6 of those. 6 of those. There's a pattern on this side too, but they're not in number of 6. What it means is these details and then do that in one circular feature. One circular pattern feature. All right. So first up, we'll do the holes. Now, can I measure? We'll just see if I can get my calipers in there. Yes. And about 2.9 millimeters. Now I'm going to make that horizontal to the origin. And if I could measure them center to center, I would. I can't. Can I do outside? Not quite. Look about 19 apart, which if I was to do this would be 9.5. That looks about right, so I'm happy with that hole. With that one hole done, I'm going to extrude cut. That can go through all. Okay. And then we've got to do the rib. So there is 2 ribs here. They're at a bit of an angle, you know, they sort of angle out from the top. So they look like they've got a bit of a curve to them on that top face, not quite flat. And they're down a little bit from this face here. What might be easier is if I this and do those afterwards. I'm going to go on, I'm going to use this face. I'm going to put in the outside shape, which I can measure, 7.4. I've then got the inside shape, which is pretty consistent. It's going to be 0.9. On this one, a bit tighter. And then the axle size, always typically 1.8. So if I grab both of those, equal. Let's just do a quick measure. 1.9 apart. This one's a bit loop on the inside. And it does have a very small fillet, which we'll put in here. Okay, I'm going to grab those and do a circular pattern. This is a sketch pattern. I'm going to grab that origin, that center point, put it there, and then a dimension between the arcs, those line segments. All right, so now I'm going to extrude down, and I can see that this face is not quite at the same level as everything else. It's a bit below. It's difficult to measure. I'm going to eyeball it as 2.5 millimeters. Now, when I'm extruding this, I'm going to go down up to surface. I'm going to select my contour as this shape plus these 4 contoured sections. And then I'm going to select from and make that offset and change the starting position. That's okay. Pardon me. Sorry about that. All right. So putting that detail in is just going to help me with the height I need for the next one. Visually get it right. The other thing I can do is cut that hole all the way through. Now, it does look like on the other side that it's a flat face in here. So while there's the curve in the model here, I'm actually going to remove that. So I might do this step next. Rock crawler, hello, thanks for joining. We are modeling some Lego parts. All right, let's do this next one. For this, I'm going to do it on the other side. I'm going to get the outer diameter, if I can. It's a bit tight. Like very close to 12. I'm going to put in 12. The inside bit, I can measure that width, 2.3. If I offset that, 2.3 to the reverse, it'll be the inside. Now, how deep this one is, it's a caliper for that. 5.4 from this face. I'm going to extrude down up to surface, offset 5.4. And then the bit is we need to make this face flat. To do that, and select this sketch. I'm going to go to the contours and just select that inside section. And it's just a case of measuring from this face down about 3.8 millimeters. So I can use that dimension. I can say I want to extrude cut from this down 3.8. Right, now this is showing me that somewhere my dimensions are off. Let's say all bodies. And what it's showing me, if we do a section view through here, is that with all those dimensions worked out, something is quite wrong in how far this cut comes down. So perhaps it is the arc that we have in the middle. Let me change my sketch to right plane sketch. And there is our original sketch. So we can see the issue. Okay, the issue is here. Deep. If we changed how deep this arc was, remember we can't measure this one, we just kind of guessed. You can see when I put down all of a sudden it makes it a solid body again. So what I'm going to suggest is that this should be close to this kind of dimension. And now what's happening is when I try and do this cut, it's not quite reaching. That could be a couple of things. That could be that the whole position of this arc is wrong. So instead of being 1 millimeter here, it could be a bit bigger, 1.5. This could be more, 10.5. Now the cut works, but the shape, you can see the shape, we lose that consistent wall thickness. So I'm still not 100% convinced either way. We don't have full consistent wall thickness everywhere. So maybe this should be 1. Maybe this should be 1 as well. Maybe that's going to help. Yes. Bring this back to 10. And all of a sudden with those tweaks, look, that cut is looking okay. The thickness here is looking okay. I think that's a pretty good solution. So just tweaking by eye, feel as we go, make sure it's still strong. Now, I can come back to this sketch, do an extrude cut, select this contour here and go through all. That creates my hole all the way through. All right, we're getting there. Let's jump back onto the front face. We're going to do these 2 ribs. So that is, and the interesting thing with those, I said that they've got a curve. It does make it a more complicated part to do because it's not a flat face. If it was flat, I'd sketch on this face and straight down. Because they're curved, I can still do the extra cut afterwards. That might be a good way. Let's go on this front view. And let me do 1. Just going to sketch it in roughly. So I'm going to measure, very thin, of course. It's only 0.9, close to 1, but go 0.9. At the very inside, it's kind of cut around in a circle. It's not like a true flat edge. So you see in my sketch, I've kind of got this square edge here. It's not like that at all. I can measure that approximately about 9 millimeters. So I'm going to put in that sketch. 9. Okay. I'm going to mirror this sketch. I'm going to drop the edge down here. I'm going to remember that they actually start, well, I can actually just bring them right up here because it starts on this face. Okay, so having them fully defined up here is fine. I'm going to just put sketch point here and here. So I'm going to use those as a reference to dimension, like the outsides. Close, 3.5. What I'm trying to do is get these fully defined, obviously, so that they're reasonably accurate. And 4.2, the ones at the bottom. Now that should bring them, right in. All right. Now, the other thing I'm going to do is select this face here, and convert. And so I've got a couple of sketches that you can see. When I hide, make the body see through those lines a bit easier. This helps me visualize. And my plan is to do these 2 ribs and then cut the top off them. So I'm going to go extrude, select the contours, and go up to, I can do up to next or up to body. I'm going to go up next, but I'm going to offset them, and I am going to offset them down to where it looks like they start, which is just below that first chamfer out there. Be a little bit more. Like that. And merge. Okay. Now the fun bit. Get rid of, or to get the shape correct. I'm going to go to the right plane. I'm going to do a section view. We can see in the that that face curves down and ends below this middle face. So when I look at my sketch on the right plane, I'm going to draw an arc. I'm going to draw the arc from this point and get into this. I'm just going to drop it right. I want to drop it here. Try that again. I'm actually going to use the outside face. I'll show you how to use that as a selection in a second. So if I want to intersect with this face, there's no sketch there, and because it's a section, I can't, select that line. There's no pierce point. What you can do is create construction geometry. I'm going to use this curve. I'm going to select this face. I'm also going to select this face. And what this is going to do is create a sketch which is intersecting with this face and the current plane that we're on. It's going to create that line for me. It creates 4. Got some on these other end too. I'm going to delete those. But what that gives me, geometry, which I changed before construction, gives me something to drop that and make it coincident. All right, that's going to help me fully define this. Because now I can say, okay, from here to here, it's 1 millimeter. And from here to here, that's also 1 millimeter, for instance. Finish it off and make this line. All right. That is that we can cut revolve to get the top edge off. I'm just going to close it up. To do that, I'm just going to add some more geometry. Can just bring it in here to get it fully defined. All right, so that's what we're adding. That's the profile we're going to cut. I'm going to do and I'm going to revolve it around this. I need an axis. I can look for a temporary axis, which is here. Press OK. And we have cut the tops off those 2 ribs. Now we can grab that circle, that hole we did earlier, this extrude, this cut revolve, do a circular pattern, equal spacing, 6, 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 , 6 we go. This side is done. I'm happy with that. All right, we'll do the other side, which is those ribs around the bun. So on this side, we didn't put this in before, but there is this sketch here. Come on, camera, focus. There's this bottom detail, little pip. Need to put that in. We could do that with a little slot like this. Just need to dimension it. 3. And 4. So 3 that way. Oh. It is, what did I say, between here and here is 4. Drop this one in forward slightly. And I drop it here. And drop these points on this one. That'll be. I'm just exit and rebuild, edit the feature to select those contours. This cut. Just updating the feature parameters. That one's okay. Hello, leaky gasket. I guess you didn't see in the thumbnail that this is SolidWorks, which is okay. Welcome. You have the set in the thumbnail. Awesome. Every Kev who's in the chat also does. Thanks for joining. What I am doing is modeling this cycle. These are the parts we've done. The green ones, the orange ones are the ones we're doing. Or do. We're not going to finish today. And right now, I've just modeled this wheel. Hello, hello. Thanks for stopping by. Can you hear me? I assume you can. All right, let's do those little holes. So they're tiny. There is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a pattern of 10 with one missing on the bottom. Those holes are about a millimeter. And they're pretty much in the center of that. So little detail that we'll add in. So if we want to get the center point between those edges, I just put a construction line there. That helps me find the midpoint between them. Then I could put this hole in. I'm going to do this in a circular sketch pattern. Put in the 10. Instances to skip, I'm going to skip the bottom one. I don't need it. And then I'm going to press OK. Just grab that center point, drop it on the origin. There's also here, which looks like a little gate. I'm going to put that in. It's a little bit bigger than everything else. It's about 2 millimeters. Then we're going to extrude cut it. And these are about 0.2 or 0.3 of a millimeter. Am I going to 3D print these? Maybe. Don't know. We're finished. All the parts, we'll assemble them. And then see after that. I have been experimenting with 3D printed Lego. Here's one that Quite difficult to get the fit right. So they fit together. It's a bit loose. So that's experiments for another day. Right, wheel. Okay, last feature is the rib that's on the top. That rib is 1.3 millimeters wide. The height of them is 29.6. So best way to do that is on the right plane. I'm going to put a line in between here and here. Distance was 29.6 divided by 2. And then I said the thickness was 1.3. Right. So very easy feature there. And select that feature and do a circular pattern. Change that to 4. Press OK. And there is our completed part. Pretty neat. Very happy with that one. What do you think, guys? Good? No good? We'll chuck that now into the assembly with everything else. And thank you for joining, but that is going to be the end of the stream. Bye. Going camping for the weekend and to get a good night's sleep. So thank you, everyone. FPV Kev, Monty, Rockcrawler for jumping on. And also see Toby earlier as well. Hope he has a really good stream for the competition later. For anyone curious about these parts, so if you join the school community, you get access to free access to these other classes, which are all my YouTube modules, plus the files in order. Check that out. Also, you can the Discord. Also, you can get access via the links to all of the parts, so you can load your own parts, create your own assemblies, or learn from those parts in stream today. So check that out if you want to. If you don't, that's cool. Otherwise, I will see you soon in a couple of days' time or next week to finish off what's next. Got probably another 10 parts to go. So looking forward to it. Cheers, everyone. Have a good time. Enjoy the World Champs. I really hope Atse does well. But good luck to Ricardo as well. See you, everyone.